Louis Krieger. I am a fourth-year PhD student working at LIST. So I'm not going to have any slides, actually. Perfect, more of me. So my topic is also on plant water transport. More specifically, Samuele was working on how the water gets from the soil to the roots, and I look at how it gets from the roots to the leaves. So how it works is that inside the tree is like a large amount of straws, tiny straws, going all the way from the roots to the leaves, with an exit at the leaves called the stomata. These straws, you would call them the xylem, and I look into how much carbon a plant would put into building this structure and how long they actually live for. So how much energy is being invested into this water system and how much is the plant getting out of it. And I will look at that under different conditions. So looking at trees in wet conditions, dry conditions, do they build them differently, more of them, less of them, larger diameters, smaller diameters. So this is the explanation I also gave to my little sister, who thought she wanted to hear about science. As you can imagine, she was not convinced and quickly checked out of the conversation. So what do I actually do? Well, I torture twigs, very simply. So it all starts with a kidnapping. So you have to take the twig from the tree, put it in a bag, and take it with you to the lab. Then, once you're in the lab, you put it underwater, and you cut it again. And then from there, you can do many different things. So for example, I will pass dye through their veins, check where it passes through. I will put them in ice and liquid nitrogen, and of course, cut them there again. I'll decompose their bodies, so taking the leaves apart, take apart the branches, and take pictures of them, because I like it. And then from there, I will weigh these remains and have all of this data, which I will then put together somehow. So where do I go from there? I now have done all this torturing, but so far I haven't gotten any answers. It's just a bunch of different parts that it's given me. So what I do is I take this data and I check it for our different species, for different environmental conditions. So for example, if I take a species from a wet condition and a dry condition, I can look at this frozen dye that I have inside and see exactly where the water passed through and exactly which year rings, for example. So year rings are actually xylem vessels. The ring itself is the small vessels that don't grow during seasons when trees don't grow well, which is the winter, and that's how you can tell apart which year it's from. And so by looking at where these active vessels are, I can tell you how far back these vessels are active. So for example, from 5 years ago, there's still half of them working. 4 years ago, there's a bit more working. So from there, I will create a model to tell you how long these last and how much energy the plant is putting in. The long-term goal of it is to then be able to predict which plants will grow better under which conditions. So in this dry condition, in a warmer condition or more CO2, is the way that the tree constructs the xylem more efficient for growth in this species or this species? And that is how I do it. Well, if you want to talk more to a torturer or have any questions for me afterwards, feel free to contact me. I don't think there's a conversation time afterwards, but thank you very much for listening.
Terrific. That's very, very good. Well done. A great way to present.